Heated discussion around some of the 40 gig and 100 gig single mode objectives, especially on the between the two optics vendors, Finisar and Opnex. So that was fun to watch. We called it the Chris and Matt show, which was kind of ongoing offline and during the meetings. Draft 1.0 is finished. I have a whole nother slide on that one because it's such a significant thing that's happened. And basically, the bottom line is that we're on schedule for 2010. Now, an interesting thing is that there's already demand for things that are outside the official project, so that's actually okay. It's okay for things to happen outside the IEEE or to happen later, like for 10 gig Ethernet. 10 GbE happened, 5 years after the standard or so. The good thing is that the architecture is really flexible, so it allows for a lot of extensions, and there are things that have been put in there for future technology. So we can expect a lot of MSAs. MSAs are multi-source agreements where basically a bunch of people get together and do something. Again, that's okay for it to happen outside the IEEE. The IEEE is really responsible for defining a standard and architecture and less responsible for specific implementation decisions. So draft 1.0 is here. Everyone's pretty excited about that. It's a really, really significant milestone because it captures all the technical objectives. Now, I was going over my slides with some of our standards guys, and they were chastising me for not having read the entire document. And it's okay, it's 292 pages long, and they're like, well, the question that you just asked is answered on page 75, clause 2 or something, but I don't know, I haven't read it. So apparently it is long and very detailed. So draft 2 will be technically complete, and I just want to kind of talk about where we're going, and people ask me all the time, when is it going to be ready, and when we're going to see product. So I just kind of want to, I don't want to sound, basically, we're not quite there yet. I don't want to sound negative, but I just want to, caution people that there is some hype around 100 gig and 40 gig, and that there's still a lot of stuff that could change. So basically, 1.0 captures all the objectives, but when you have something on paper, then you go and actually try and build it, there's stuff that's going to come up, and the IEEE calls this crossing the I's and dotting the T's. See, they do have a sense of humor. And then there's always a careful balance between market timing and the standards process and compliance. So there's 3 drafts here that come out: 1.0, 2.0, and 3.0, and each one will be more and more of a standard. So as time progresses, there's more of a certainty of being standards compliant if you base your implementation on draft 2 versus draft 1, or draft 3 versus draft 2, or something like that. But people can actually start to evaluate what it's going to take, how they're going to do it, and start at least scoping out the implementation based on draft 1. So that is the good news. Here's a summary of the reach objectives and specifications. This is an old slide. The difference is that the solution has now been defined. So, for example, we're still trying to figure out, is 100 gig going to be a 10 by 10 solution or 4 by 25? All those things have been worked out. And then again, here you see all the nomenclature, the 40 GbE KR4, and I have a slide in the back that helps you decipher all that kind of stuff. Here's a very extremely complicated slide, and I apologize that it's so dense, but I wanted to put everything on one slide so that it makes sense at least. Here's an overview of the architecture. Basically, all the stuff above the Mac is the same, and all the stuff below the Mac changes. So it's the same frame format, same control and all that kind of stuff. The other thing that's changed is that there's some new interface definitions below the Mac, and then of course higher rates. So the thing that I really want to point out is in these blue circles, which you probably can't see unless you have the presentation in front of you, but this is basically where some of the flexibility is in being able to cope with future technology. So eventually everyone wants to do 40 and 100 gig serial, but unfortunately it's just not possible with the current technology. So right now it's going to be a multi-lane solution for 40 and 100 gig. Eventually though, we'll get there with technology that will allow us to do it serially. So you can see there's already some provisions in there for actually doing multi-lane down to 1 lane, which would be serial. So the sort of interesting objective that's just completely undefined is provide appropriate support for OTN. We've talked about this a little bit before. Basically, 10 gig Ethernet has what's called the WIS, which is the WAN interface sublayer. I think that's kind of a fun word to say. It's missing from 40 and 100 gig because they've taken that out. In 10 gigs, it's actually kind of complicated and a little bit awkward because you have to translate 10 gig Ethernet into SONET framing, and it doesn't actually run at 10 gig line rate because of the framing. So there's been a lot of work between the ITUT and the IEEE to transparently map Ethernet into the SONET infrastructure. And the other thing I want to point out is I have these little URLs at the bottom which point you to the full presentation. So these are all available to the public if you want to download and read all the details. But basically, it's been worked out between the ITU and the IEEE about how exactly that's going to happen, and then who's going to define how that works. And then the other interesting thing that I've always been mentioning is, we want Ethernet to be as reliable and have some of the same characteristics as far as troubleshooting and monitoring that people like about SONET. So link fault signaling and those kind of things are feasible. It's not in the specification to work, but there's no reason why that shouldn't work for OTN. Okay. Obviously there is something wrong. Todd? Yeah, you're right. I should have checked these slides. Okay, so let's talk a little bit about the specifics of each type of objective and in more detail, and I try to kind of make this applicable to operators, which unfortunately is under the text. So the backplane solution is kind of interesting, not necessarily for running a big network, but in terms of what can happen with blade servers and that kind of technology. This was really heavily, I don't want to say pushed, but Intel and some of the blade server vendors had a big interest in this, and I think it's going to be interesting what the possibilities that we see with high density and high capacity blade servers in the future. But basically, this technology is going to auto-negotiate from 1 to 40 gigs. So as server capacity and capabilities increase, I think blade server is going to be very interesting. It basically is based on 10G base KR, which is the 10 gig backplane specification, and it does sort of the same things. Now, the one bullet that I kind of want to talk about is influence of IEEE. So IEEE is a project in the IEEE called Energy Efficient Ethernet, and it's basically introducing some new control frames to drop the power when systems are idle, to reduce the usage. This will probably have an influence on the backplane technology. You can see if you have a bunch of blade servers that could have a 40 gig capacity and they're not doing anything, it makes sense to kind of drop that utilization or the capacity down to 1 gig and then raise it again when they're busy talking. Okay, looks like all these are broken. So the copper cable specification basically also reuses 10G base KR, and the cable parameters are based on 10G base CX4. I think CX4 is personally a terrible and awkward connector. I hope we don't have to reuse that, but the cable parameters are based on CX4. It also does auto negotiation, and then the other thing I want to point out is that we're trying to figure out how to make a connector for this kind of stuff. So the current proposal is that a 4-lane solution would use QSFP. QSFP is the quad SFP. It's basically a high-density pluggable media that has four lanes in it. And then a 10-lane solution would use something called SFF 8092. It's a new small form factor pluggable standard that people are working on. But again, it's just a high-density connector for copper or fiber. For the 100-meter OM3 multimode fiber solutions, basically it's a parallel solution. I don't want to say it's a ribbon cable because that kind of gives people the wrong impression, but it's going to be some sort of high-density fiber connector that would go into a high-density connector. And then people have been talking about, well, we want to make things go further than 100 meters. Can we do 200, 300? And then the OM4 fiber manufacturers are talking about, well, we could go farther over OM4. So this is possibly one technical objective that still could be amended based on what people are able to actually do when they get some samples working. The 40-kilometer single mode solution, this was one of the heavily debated ones, and the bottom line is that it's going to use a CWDM grid, and it's going to run these lambdas. And then the 100 gig single mode solutions, again, one of the heavily debated objectives in the IEEE, and this one is going to use the LAN WDM solution. And the thing that I want to point out here is that, again, we're talking about flexible architecture and future technology. So right now, if you notice on the back end, going into the block diagram, it's all 10 lanes of 10 gig. So basically, this is based on a 10 gig SerDes and 10 gig electrical technology. So as we get the capability to do faster electrical technology, we can basically whack off the whole back end of that and just do 4 times 25 gig into the block, and then that'll save a lot of costs and components and things like that. So this is just an example of how technology can change and how this is kind of built to already allow for that technology in the future. And then those newer generation components and technology will allow us to drive the cost down. The 100 gig 40 kilometer is basically the same diagram. You notice that there's just an amplifier in there because it has to go further, and this uses the same grid spacing. And again, same thing here. We have 10 lanes of 10 gig going into the block, and as we have new technology, that'll allow us just to do 4 by 25. All right, where are we now? So it's almost been 3 years since I started doing these updates, and we're at least halfway there. Again, draft 1.0 is a big achievement, and basically, summer of 2010, we'll see the standard. Here's a much more detailed timeline from the IEEE. The things I want to point out here are the draft 1.2.0, 2.0 and 3.0 dates in here. So when you're talking about when vendors are going to have technology, kind of keep these dates in mind because these are when the big changes happen. And one question, like I said, when are we going to have this? Well, if you look at the timeline, draft 2.0 is going to be the last technical change. So I think people are going to have a reasonably good idea of what's going to happen by sort of summer of next year. And then if you figure it takes 3 to 6 months to do an ASIC, then ASIC vendors have to sell that to router vendors have to take that, put it on the board. So I think we'll start seeing some product out there by end of year 2009. I think that's a pretty reasonable date. Future meetings, basically, the meetings are going to get really boring. Comment resolution is probably one of the most tedious things that I've ever been through in my entire life. It's basically where you look at every word of the draft and criticize every word. So this is like, there's a comma missing on this sentence, and like a ticket gets opened for every comment, and then we all sit in a room and go over it and vote on accepting the changes. And there's a lot of technical changes that happen too, but I mean, you go over it with a fine-tooth comb, and that'll take several meetings, actually. Here's the website. Everything, like I said, is public. You can download it and read about it in as much detail as you want. Here's the nomenclature. This is just for your reference, really, but that explains, how we come up with all these fancy nomenclature. And then these last 5 slides are just, the detailed how we get there. And there's the standard. Want to answer questions? Yeah. Any questions?
Hey, Todd Underwood. There are rumors and insinuations that there are existing vendor implementations. Can you talk about your companies or any of your competitors and what the timescale for that is, and whether those are pre-standards or what standard they're implementing to?
Yeah. So there's been a lot of demos, and this is good because it's good for people to demo the technology. There's been a lot of demos specifically around 100 gig technology, and I say 100 gig technology because that's what it is. It's not 100 gig Ethernet because it's not based on the standard. It can't be Ethernet until the standard is done. But it's good that people are thinking about that technology. Again, I would just say that the draft schedule is pretty well defined. So draft 1.0, we have a pretty good idea of what's going on. Draft 2.0, we have a lot better idea, and then draft 3.0, the standard is pretty much done. So anything that people are talking about right now, draft 1.0 just came out a few weeks ago, so it would have to be really pre-standard. So I would just caution people to use this timeline and evaluate what vendors are saying.